Okay, welcome to our third example on double integration. So here we have our third integral, and notice this time that this is not a product. This is a sum of x squared and y. So we can't just pull out x squared when we treat it as a constant. We have to actually integrate it. So yeah, our first integration is going to be with respect to y. So with respect to y. So if I was to integrate this with respect to y, I get x squared y plus, right? I just tack a y on there because it's just treated as a number, plus y squared over 2. That's a squared. And we're going to integrate this from x to 4 minus x, right? We're just copying our bounds. And then afterwards, we're going to integrate with respect to x, right? That's after we evaluate this. So now we're going to evaluate, right? So we're going to our second integral. So now we're going to put all of this, because we just integrated with respect to y. This is going to go into the y. Oops. This is going to go into the y. On the y, my pen is freaking out. This is going to go in with the y's. And afterwards, this x is going to go in with the y's, right? Just they go into the variable of integration. So let's plug them in, right? X squared times 4 minus x. 4 minus x. And then plus x squared, 4 minus x over 2. Oops. Okay, plus 4 minus x squared over 2, right? All of this business. Then we're going to subtract, because we have to do our second bound now. Subtract x cubed plus x squared over 2. And then we're going to eventually integrate this entire thing with respect to x. So obviously we're going to have to simplify first, right? So let's simplify it on that integrand. We could start by maybe foiling this, right? 4x squared minus x cubed, right? And this is the whole thing here. Plus, let's try and foil this in our head. We get 16 minus 8x plus x squared over 2, all that over 2. Then we distribute this negative, right? Minus x cubed minus x squared over 2, and eventually in the future we're going to evaluate that with respect to x, right? So maybe we can replace this by, let's see here, 8 minus 4x plus x squared over 2. 8 minus 4x plus x squared over 2. Let's see if I remember that. 8 minus 4x plus x squared over 2. Okay, I think I got it. So let's try and see if we can combine anything here, any like terms. 4x squared, you go with the x squared, and you go with the minus x squared. Well, these cancel out, right? So now we just get a 4x squared minus, so we get minus 2x cubed minus a 4x, and then plus an 8. And I'm going to integrate that with respect to x, right? So we're running out of room. Let's go back to the top. I have to invest in a screen that can scroll down, so I don't have to keep erasing. Let's do all of it just in case I still have some more room to go through. So now we're going to integrate with respect to x, right? Oh, that was a cubed. Hold on a minute. That was a cubed. All right, so let's integrate this. So now we get 4x squared. That becomes 4x cubed over 3 minus 2x to the 4th divided by 4, right? I'm just doing reverse power rule. 4x squared over 2 plus 8x. This is going to be evaluated from 2 to 0, right? So now we're going to plug a 2 in to where all those x's are. So 4 times 2 cubed over 3, that's going to be 4 times 8 over 3, right? 2 to the 4th power, that's 16, so minus 2 times 16 over 4, minus 4 times 4 over 2, plus, that's just going to be 16. And as I predicted, we're probably going to run out of room. Okay, so now we keep evaluating. This is a times, not a minus, right? So 32 over 3. 32 over 3 minus this becomes 32 over 4 minus 16 over 2 plus 16. Right, and these are, of course, not nice fractions. So we have to try and get a common denominator. Let's try and think of, let's try and use our handy dandy calculator because I'm tired right now. 32 over 3 minus 32 over 4 minus 16 over 2, which is the 4, plus 16. You get 32 over 3 as your final answer, which is 10 and 2/3, so about 10.6, 10.6 repeating, 32 over 3, which is approximately, or which is equal to 10.666 repeating. And that's your answer, 32 over 3. Hope that helps.